Hello students, welcome to the VAIR community once again. This is a video on one of the LRDI sets of CAT 2023. We'll take a look at the set first, all the information that was given in the set. We'll also glance through the questions and then we'll come back and try and solve the set ourselves. So this is the set. If you have taken a look at it before, you might be aware of this set already. There are 9 boxes arranged in a 3x3 array shown in tables 1 and 2. Each box contains 3 sacks. So every single box contains 3 sacks. Each sack has a certain number of coins between 1 and 9. So first of all, you have to realize that every single box has 3 sacks, and each of those sacks has a number of coins between 1 to 9, both inclusive. The average number of coins per sack in the boxes are all distinct integers. So there are 3 sacks basically, right? And the average number of coins per sack. So the average of these 3 is distinct from the average of these 3, which is again distinct from the average of these 3. So basically, can I say that the average of this box is different from the average of this box, is different from the average of this box, and so on and so forth. So you will get 9 different average numbers because each of these boxes has a distinct integer as the average. The total number of coins in each row is the same. The total number of coins in each column is the same. So you have the same number of coins here, you have the same number of coins here. Table 1 gives information regarding the median of the number of coins in the 3 sacks. So these are basically the medians of the coins in that particular box. For example, in this box, the median is 9. Now, we know that if the median is 9, it is the middle value that we talk about. And there are 3 sacks in every box. That means there's going to be 1 box on this side and there's going to be 1 box on this side of 9. And we also know that the medians are calculated when we write down the numbers in ascending order. So if at all, I have to write down a number here and a number here, I can definitely say that these values can both either be 9 or this value is going to be lesser than 9 and this value will be equal to or more than 9, right? So that is the understanding of this particular statement. In table 2, each box has a number which represents the number of sacks in that box having more than 5 coins. So let's take a look at this value itself. In this box, there's 9 as the median, and corresponding to that is this box in table 2, which is there are 2 numbers that are greater than 5 in this particular box. That is what this means. And then the last bit is that number, that means 2, is followed by an asterisk if the sacks in that box satisfy exactly one among the following 3 conditions. These are the 3 conditions. And it is followed by 2 asterisks if 2 or more of these conditions are satisfied. So here we have one number is satisfied, that is one condition is satisfied. Now, which condition is that is completely left for us to understand. The first condition here is the minimum among the numbers of coins in the 3 sacks in the box is 1. That means the minimum number can be 1 if this condition is true. Second condition is the median of the numbers of coins in the 3 sacks is 1. So the median has to be 1 for some of them, if at all. And the third one is the maximum among the number of coins in the 3 sacks in the box is 9. So I can have a maximum of 9 here. This is what we have to follow through for each of the boxes. Now, the idea is to fill in all the numbers of the boxes and then go to the questions. But let's take a look at the questions as standard practice to understand at what depth can the questions be asked, or are they easy, or are they medium, or are they difficult in terms of the level of difficulty. Question 1 is, what is the total number of coins in all the boxes in the 3rd row? Okay, so they've asked us this. How many boxes have at least 1 sack containing 9 coins? So it's a straightforward question again. For how many boxes are the average and median of the numbers of coins contained in the 3 sacks in that box the same? So you want the average and the median to be the same. How many sacks have exactly 1 coin? That is question number 4. And in how many boxes do all 3 sacks contain different numbers of coins? These are the 5 questions that follow the set. So we have to segregate our understanding from the sacks and from the number of coins. Right? The boxes have 3 sacks each, and each of the 3 sacks has a different number of coins or the same number of coins, depending on what is the average basically and what is the median as well. All right, now that we've gone through the entire set, let's try and solve for each and every number here. So just a few things that are mentioned in the previous slides itself, just writing it down in short over here. Each sack has a certain number of coins between 1 and 9, both inclusive. There are 3 sacks. The average number of coins per sack in the boxes are all distinct integers. Now let's write this down. So we have the average number of coins as distinct integers. That means what could be the averages of these? Each box contains 3 sacks, so we know that. So each of the boxes has 3 sacks. Since these numbers are medians and there are 3 sacks, the middle number is going to be a part of the sacks as well. So the middle number here is basically 9. That means the second sack in this particular box has 9 coins. Likewise for 2 also, for 8 also. So this is one of the sack out of the 3. And 6 is also one of the sack out of the 3, right? And then we're going to fill this in ascending order as much as we can. So each box contains 3 sacks. Each sack has a certain number of coins between 1 and 9, both inclusive. The average number of coins per sack in the boxes are all distinct integers. The average are distinct. Now, when we talk about average of 3 numbers, clearly, so you're going to do this plus this plus this should be divisible by 3 because they want them to be integers, right? And they want them to be distinct as well. That means the additions should be a multiple of 3. So I can have 999 or I can have 111, etc. Everything that can be divisible by 3 because I want them to be integers. Right now, what is the largest that you can have as a sum over here? I can have 9 plus 9 plus 9, which will give me a 27. So basically, the table of 3 I'm going to write down all of them, right? So if the average is basically anything like 1, then the total, the sum of the numbers in the box should be 3. If I have the average of 2, the sum has to be 6. If I have an average of 3, the sum should be 9. If I have an average of 4, the sum should be 12. Likewise, 5 will give me 15. 6 will give me 18. 7 will give me 21. 8 will give me 24. 9 will give me 27. Now, we saw that 27 can be the largest sum because you're only allowed numbers between 1 to 9. Okay, so there will be one of the boxes which may have 999. That's why we get the plus 27, because all of them have to be distinct integers. The averages are all distinct. And these averages are 9 numbers, and we have 9 boxes as well. So one box will have an average of 1, one box will have an average of 2, and so on and so forth. Remember to not get confused between the average and the numbers that are given over here. These are the medians, right? So now I need to see what is the total that all of these make up, right? So I have the averages over here and I have the sums over here, right? Now what I need to see is the sum basically has to be an even distribution, because they've also said that the total number of coins in each column and each row is the same, right? So if I add up the sum, all of these together, basically it'll be 27 plus 3 is 30. Then 24 plus 6 is also another 30. So I'm adding it that way. 27 plus 6 is 30. Then this is another 30, so 60. This is another 30, so 90. 12 and 18 is another 30. So that will be 120. 120 and 15. That means the sum is 135, right? Now 135 divided by 3 basically will give me a value of 45. That means the sum in every row and every column should be 45. So the first row, the numbers should add up to 45, and also the first column, the numbers should add up to 45, right? Same likewise for column 3, column 2, column 3. Likewise for column 2 and column 3, and for row 2 and row 3 as well, right? So everything should add up to 45. That's the whole understanding of this. Now let's start off with what could be the numbers. We'll start filling in the numbers. Starting with this number itself, or this box itself, because we had taken a look at the median is 9. What could be the 3 possible numbers? I can see if the median is 9 and I want to keep all the numbers same, it will be 9 and 9. There's no higher number that I can give more than 9, right? Because you are allowed numbers between 1 to 9. So this number is going to be a 9 anyway, but let's also correspondingly take a look at table 2. They're saying there are 2 numbers in this box which are greater than 5. Table 2 is the number of sacks in the box having more than 5 coins. So these are the number of coins which are greater than 5. There are 2 numbers in this box which are greater than 5. Clearly this number is a 9 then. And then this one can't be a 9, because then otherwise this would have been all 3 are greater than 5. But that's not the case, right? So I have 2 9s, and then one is a smaller number smaller than 5, or equal to 5, not more than 5. There's also one condition that the box follows. Which condition could that be? Let's take a look at this. The minimum among the number of coins is 1. That is one condition. The median is 1. This is clearly not true because the median is 9 over here. It could be 1 here, but let's see the third condition also, because I want to make sure only one follows, not the others. The maximum among the numbers of coins in the 3 sacks in the box is 9. So I already know that the maximum is 9, right? So that means the minimum cannot be 1. Otherwise, 2 conditions will be followed, but I have only one asterisk indicating that only one of the conditions is followed in this box, right? So now we resort back to the average and the sums that we had taken over here. 9 plus 9 gives me an 18 already, but I need to add a third number, which will also be one of these sums. So I will just ease this out a little bit for our purpose to understand which values are available. So 9 and 9 give me an 18. This value has to be anything between 1 to 5. So which value is possible? I'm writing it down over here, 1, 2, 3, 4, and 5. If I put a 1 here, the total becomes 19. 19 is not in any of the additions, because 19 divided by 3 will not give me a integer value, which I need averages to be a distinct integer every time, which means 1 cannot be added over here. So let's eliminate 1. Can I do the same thing with 2 and check? 9 and 9 is already an 18, plus 2 gives me a 20, not divisible by 3, so that is also out. Likewise, 3, can I add a 3? That'll give me 21. Yes, if I take a 21, my average of this box becomes 7. But let's continue with 4 and 5 and check if I can get an answer there as well. If I put 4, I have the total as 22, not possible because it's not divisible by 3. If I put 5 again, I get the total as 23, again, not divisible by 3. So my only possible number here is going to be 3. So this is how I get this value as 3, 9, and 9. I've taken care that only one condition is satisfied over here, which is the maximum number is 9 of any of the 3 sets, right? So I have a 9 maximum, I also have a 9 maximum, and I've made sure that that condition is satisfied, and also that the sum is one of these values. So now I'm going to just write things down over here just to be absolutely clear. So 7 and 21 is the pair that is taken care of. The total for this box is 21, and the average becomes 7. Likewise, we're expected to fill up all the 9 boxes basically, and then answer the questions that followed. All right, now what would be another approach here? So we have to try and see what is comfortably solvable and then try with that. Now here they're saying there's only one box which is more than 5. We already have an average of 2. And there are 2 conditions that follow. If one of the boxes is more than 5, let's see what it can be. So the first box can either be a 1 or it can be a 2. They're saying also that the maximum has to be. Now, this also has to follow the conditions that the sum has to be one of these values. So let's see what we can have in this case. If one of the numbers is greater than 5, I can plug in a 9 over here. And then in that case, the third condition will be the only one that follows. The median is definitely not true because the median is 2, it's not 1. So the second condition is not true for this box. If I look at the first one, the minimum among the number of coins in the 3 sacks in the box is 1. All right, if I give this a 1, then what can I give the other number so that this addition is again divisible by 3? So 3 is already gone. One of the numbers has to be greater than 5. Okay, so 3 is out. The sum can't be 3. Can I have the sum as 6? In order to have the sum as 6, this number will have to be 3. But I need one number greater than 5. So this number cannot be 3. Can I have the sum as 9? If I have the sum as 9, I can do 2 plus 1, 3. And then plus what will give me a 9? So I can have this number as 6. Right? So if that number is 6, does it follow my circumstance, which is given in table number 2? If it does, then I can definitely go ahead and mark it like that. I can have a 6. Let's see. So if I take a 6 over here, it might work. One of the numbers is greater than 5, but I also have to make sure that there are 2 conditions that follow. This one is not in. That means condition number 1 has to follow and condition number 3 has to follow. Condition number 1 is the minimum among the box is 1 and 3 says the maximum is 9. So it cannot be 6 then. Clearly, it has to be 9 automatically. So my third number is automatically 9. It has satisfied 2 conditions. That is the first and the third. And it has also satisfied one number greater than 5. Right? So I've got this particular box as well filled up. That means, again, which values are gone out of here? The total is 12. So total is 12. That means the average is 4. So I have a total of 12 and the average of this box is 4. So these two are out of contention. All right, let's check for another box now. Let's see if, okay, I have all three of them. For this particular box, I have all 3 of them above 5. So let's check this. This is already 8. I need all 3 of them above 5. I can have 8, 8, 8, which will give me a 24, which is fine. Or I can have, if 8 is a median, what else can I have in order to make this as a constant thing? And there's only one condition that follows. Clearly, if all of them are above 5, condition 1 and 2 will definitely not follow. That means the third one has to follow. So one number is 9 for sure. If one number is 9, condition 3 is being followed. How much is the total so far? And then what will this number have to be? 8 and 9 gives me a 17. So 17 plus what now is going to give me a multiple of 3. But this number again has to be greater than 5. So if I put a 6 over here, that will give me 17 plus 6, which is not fine. It's 23. If I take a 7 over here, then I have 17 plus 7, which is a 24. 24 is there as a value. So I will be having this number as 7, which means 7, 8, 9 is my this box filled up of. I hope you realize why I can't have an 8, 8, 8, because if I have an 8, 8, 8, the median will still be 8. I'll still get a 24, but none of these conditions will be satisfied. And I want one condition to be satisfied here, right? So that's why I took the 7, 8, 9, which gives me a total of 24, and it gives me my average of 8. So average is also 8, and the median is also 8. So 8 and 24 is out of picture. So we're done with 3 boxes so far. Now we know that column-wise, the total has to be 45. We took a look at that. And row-wise also, the total has to be 45. So let's see, 24 plus 12 gives me 36. 36 are over out of 45. That means the total of the first box here should be 9. If now the total of the first row should be 9, then the average has to be 3. So the average of this row is 3. And I also know that there's only one number greater than 5, and there are 2 conditions that are being followed. If there's one number greater than 5 and 2 conditions being followed, which ones can those be? I need a total of 9. 1 condition or 2 conditions being followed. If I try and see the first 2 conditions, that is a minimum among them is 1, and the median of them is also 1. Does that work? Let's try that as an example. If I take 1 and 1, see, I think those will have to work because if I take the third number, the maximum is 9. If I take the third number as 9, the addition is 9, right? So then these 2 will have to be 0, but we don't have 0 as a possible number, which is why the third one is out. That means the first 2 have to be the ones that are being followed by this particular box. So I'm removing the 9 and I'm plugging 1 and 1. The minimum value is 1 and the median is also 1. So these 2 are the ones that are being followed. And now if I want the total to be 9, the third number has to be 7. So 1, 1, and 7 is this particular box. The total is 9 and the average is 3. So this is also out. Now, just like we filled up this particular box, similarly, the total of this row will also be 45. Can I try and see now what is left for my total for the third column's first row box? So I have 21 and 9, which means 30 is already out. Out of 45, 30 is gone. So I need the addition over here to be 50. And then clearly the average is going to be 5. Now for this box also, there are 2 numbers greater than 5. So it's 6 and this number greater than 5. That means this one is lesser than or equal to 5. And there's one condition being followed. Which condition will that be that needs to be followed? Can I have the minimum value as 1? Let's try. So if I have the minimum value as 1 over here, I can have 6 and 1, 7. 15 minus 7 will give me another 8. So if I have an 8, does that work? Yes, it does tell me that 2 of the numbers are greater than 5 and one of the conditions is being met. This is one possibility. Can I have another possibility here as well? Let's check. If I take a 2, then 2 and 6 gives me 8. That means I need my third number to be, this is 8 already. Out of 15, 8 is 1. That means I need this number to be 7. Okay, so this is also possible to make a 15. However, is there any condition that is being followed with 2, 6, and 7? There's no condition. Minimum number is not 1. The median is not 1. The maximum is not 9. That means all three conditions are not being followed with this particular approach, right? Can I go ahead and see with 3? Instead of 2, 6, 7, can I fill the first number with 3? If I fill the first number with 3, the second one is already 6. So 6 and 3 gives me a 9. And 15 minus 9 will give me a 6 again. Can I, again, there's no condition that is being satisfied with 3, 6, and 6 either. I can still get a 15, but there's no condition. If I take a 4, my third number will go less than 5 or 5. So if I take a 4 over here, this is a 10, and then this will be 5, which is not possible because 6 is the median, 5 is not the median, right? So none of the other conditions basically work, and that is why I'm going to settle on 1, 6, and 8. And that is how we get to complete this particular box as well. So 5 and 15 is also out of contention. All right, now we are left with 1, 2, 3, 4 pairs, and we're clearly left with 4 boxes to fill them in. Let's try and see what can be done next. So if I go by the options here, all three numbers here are greater than 5. All three numbers over here are greater than 5, and there's one condition being followed. So if all three are greater than 5, I cannot have the first one and the second one as a possible condition. The third one is a condition. That means the maximum of the box is 9 for sure. And all three numbers are greater than 5. Here, none of the numbers are greater than 5. Here, none of the numbers are greater than 5. And here, there are two numbers greater than 5. Now, we have to go back to the sum and the average that we've seen. What are the sums that have not yet been covered are 3, 6. So these are numbers which are not more than 5. So it's possible to make a 3 and a 6 from numbers less than 5. Here, there are two numbers that are greater than 5, which can be the 18. But for 27, I need all the three numbers to be 9. 9, 9, 9. That's the only way to get a 27, which most likely is going to be this box because there's no other boxes that are giving me all three numbers greater than 5, which then it tells me that this box is filled with 9, 9, and 9, which gives me the addition of 27 and the average of 9. So we are done with 9 and 27 also. Now let's look at this bit. If I can figure out what is the total that is remaining over here, I'll get to the answer. So 27 plus 12 is giving me a 39. Out of 45, if I remove a 39, my sum over here has to be 6. That means my average should be 2. If I need a 6, and if none of the numbers are greater than 5, what can be the values? I also need to make sure that one of the conditions is satisfying this particular box, which cannot be the third condition because I need all the three numbers to be less than 5. So the third condition is out. It has to be either the first or the second. What can it be? If it is the first, then if the median has to be 1, then both of them will be satisfied. I cannot have the median value as 1 and then not have 1 repeating because I cannot have a 0 here, which means only the first condition is true in this case. That is 1 will be over here. The median cannot be 1. However, I need to make a sum of 6. So I have numbers 2, 3, 4, and 5 possible. 5 is not possible because 5 plus 1 gives me a 6, but I want 2 more numbers to be filled in. Can I have a 4? If I take this number as 4, then this will have to be a 1, which will make 2 of the conditions true. But here it says only 1 condition is true. So I cannot take a 4 either. Then I can take a 3 and then this will be a 2. Would that work? That would absolutely work. 1, 2, and 3. The total is 6. The average is still 2 and only one condition is satisfied, which is the first one. Right? So we've taken care of this box as well. I hope we're clear so far. There are just 2 more boxes to go and then we're done with the set. All right, so this box is done. This is also now, none of the values are greater than 5. And there are 2 conditions being followed. So clearly it has to be the first and the second. So that makes it easy. The first number, smallest number is 1 and the median is also 1. Right? Now the highest number cannot be 9, but we can eliminate 6 and 2 from this. And then clearly if 6 and 18 is going to go to these values because there are 2 numbers here greater than 5. So here the sum cannot be 3. That means here the sum has to be 3. And the average has to be 1, which means this third number will also be 1. So you have 1, 1, 1 as this particular box. The last box that is left, we have to make a sum of 18 and an average of 6. We need 2 numbers greater than 5 and 2 conditions being satisfied. If 2 numbers are greater than 5, I cannot have the first 2 conditions being satisfied, which is says 1 and 1. I can have the first and the third being satisfied. Second and third will also not be satisfied. So 1 and 3 are being satisfied here. So the smallest number is 1. The largest number is 9. So 10 is 1 out of the total of 18. That means the second number has to be 8. The average will come out to be 6 because that's 9 plus 9 divided by 3, which will give me 6. Here we are. We've completed all the values. We completed all the boxes, all the sacks. Everything is done. Now let's go ahead and take a look at each and every question that has followed this particular set. The first question is, what is the total number of coins in all the boxes in the third row? So in the third row, I have these boxes. And we've already known that row-wise and column-wise, the total is 45. Let's just check that. So 24 plus 18 and 18 plus 3. Does that give me a 45? 18 plus 3 is 21. 21 plus 24 is 45. So yes, 45 is going to be our answer for the first question. The second one, how many boxes have at least 1 sack containing 9 coins? At least 1 sack means a minimum of 1 sack, but it can be 1 sack or 2 sacks or 3 sacks containing 9 coins. We want the number of boxes that have 9 coins. Okay, so this box doesn't have 9 coins. This one has at least 1 sack of 9. Yes, 1. This one does not have a 9. This is the second one. So I'll just depict it with some other ink. So yes, I have this box. This box has a 9. This one doesn't. This one has a 9. At least one sack with a 9. At least one sack with a 9, yes. At least one sack with a 9, yes. And that's about it. So how many are there? We have 1, 2, 3, 4, and 5. So there are 5 boxes which have at least one sack containing 9 points. So our answer is going to be 5. The next question, for how many boxes are the average and the median of the numbers of coins containing in the 3 sacks in that box the same? So don't get confused with the language over here. All they've asked you for how many boxes is the average and the median the same. Let's see for each and every box. So I have, for the first one here, do I have the same average? So the average is, so the median is 1 and the average is 3, so no. Here the median is 9 and average is 7, no. 6 and 5, no, not the same. 9 and 9, yes, so that is my first box. 2 and 2, yes, this is my second box. 2 and 4, no. This is 8 and 8, yes, this is my third box. 8 and 6, no. And 1 and 1, yes, this is my fourth box. So my answer for this question is going to be 4 boxes. The next question, how many sacks have exactly 1 coin? Sacks. So this is not about boxes. This is about sacks. So how many sacks have exactly 1 coin? Let's number these sacks. This has exactly 1. Basically, we're counting the number of ones that have been listed. 1, 2, 3. There is 4, 5, and then 6, 7, 8, and 9. So our answer to this question is going to be there are 9 sacks which have exactly 1 coin. And the last question for the set, in how many boxes do all 3 sacks contain different numbers of coins? All right. Box number 1, no. Box number 2, no. You want all the 3 numbers to be different. Yes, this box is it. 1 to 9 is again different numbers. This box as well. 1 to 3 is again a different number of boxes. This box clearly no. 189 is again a different number. And 789 is also a different number. So answer to this one, how many boxes? There are 5 boxes with distinct numbers in each of the stacks of them. So you realize that the set seems lengthy at first because you have to fill in all these values as such. It's not difficult, but it's a little lengthy. But once you get all these numbers right, just by correlating it to table 2 as well and the conditions, after that, all the questions are a breeze. The questions are not difficult. The questions are not leaving you in ambiguity in terms of the answers, but you're getting short answers and you're getting all the 5 questions right once your numbers over here are right. The only catch was about finding out that the total has to be 45. This is the only extra out of the box thinking that you had to do. The rest all was about statistics. It was about median and it was about the average as well, right? I hope you all enjoyed the set. If you want more such sets, make sure to like, share, and subscribe to our channel and be on the lookout for one particular set every single week. Thank you, and I'll see you in the next video.